In this video, I want to give you an introduction to Elisity Cognitive Trust, a demo before the demo. Let's take a few minutes to look at the problem that Elisity is solving and how we do it. With the convergence of IT, IoT, OT, and IOMT, both on-prem and in the cloud, traditional castle and moat security methods no longer cut it. Network segmentation based on IP access lists, firewall rules, VLANs, and other rigid network constructs do very little to stop bad actors from exploiting vulnerabilities, raising their privilege level, and moving throughout the network once they've gained access. Many of these security vulnerabilities can be remediated by implementing identity-based network segmentation. However, the identity and attributes of users, devices, and applications must be learned accurately and verified continuously so that network policy is identity-based, intelligent, and agile as it gets distributed across the appropriate places in the network. Many enterprises are looking to adopt a least privilege access architecture for their network, but most solutions that offer this are complex, hard to deploy and manage, and resource intensive. Elicity's solution to this problem is ingenious. We deliver identity-based microsegmentation to your existing access layer switching infrastructure. This means non-disruptive deployment, rapid time to value, and both north-south and east-west segmentation, all the way down to users and devices within the same VLAN. Elisity delivers network segmentation that is easily adaptable and scalable for constantly evolving networks, and gives high visibility into what assets are on your network and the traffic flows that are taking place. Customers can access all of this from a dedicated cloud control center. Elisity can onboard your access layer switches as Elisity policy enforcement nodes in a couple of ways. First, we can run our Elisity Edge software as a container directly on supported hardware. We can also run the Edge as a virtual machine anywhere in your network with a secure management connection to your access infrastructure, turning those devices into policy enforcement nodes. In both cases, deployment is non-disruptive in brownfield environments with rapid time to value. We can spin up Cloud Control Center, set up our connectors, and deploy policy enforcement nodes in days rather than months. Let's dive into Cloud Control Center and take a look at how we are leveraging data that we've gleaned about assets to create comprehensive policies. In Cloud Control Center, we have various tools like detailed traffic flow analytics, event logs, and administrative tools, but I want to focus on two things: asset inventory and policies. On the left of the screen in Cloud Control Center, we have dashboards for onboarded users, applications, and devices. Let's focus in on devices. So here's our inventory of learned devices on our network. Every device that has generated traffic flow on the network will appear in this inventory, along with all the data that we've gleaned about the device. We can then take this inventory in Cloud Control Center and compare it to your CMDB to identify any rogue devices, which we can then isolate on the network until they are either identified in the CMDB or trusted in Cloud Control Center. We can also leverage our asset inventories and policy creation to create policy objects that make policy building easy and efficient. Let's see what that looks like. So here on our policies page, we manage policy groups, manage and deploy policies, and observe traffic flows to find gaps in policy coverage. You might be wondering what a policy group is. Policy groups are the constructs that we use as the source and destination for a policy. Every policy group is made up of one or more attributes that we've learned about users, devices, and applications. We use this construct to match policies to assets on much simpler criteria like device type, printer, rather than something like IP or MAC address. These policy groups are then referenceable on our policy matrices. Let's take a quick look at our policy visualization matrix. In Graphical Policy Visualization View, we can see all of our source and destination policy groups. At each intersection between policy groups, we can see a colored square. We can see here at the bottom that blue squares correlate to Layer 7 or application layer policies. Yellow squares translate to Layer 4 policies. Red squares translate to policies where all traffic is denied, and white squares show a default allow policy, or there's no policy in place there at all. An asterisk on a square means that this policy is created but not deployed. If we switch over to Traffic Flow Visualization View, we can see that this matrix is a little different. This matrix is also color-coded, red for traffic flows blocked by a policy, and green for traffic flows that have been observed. The shield icon tells us where a policy is deployed. We can use this as a guide for critical areas where policies might be needed. Let's say we've observed traffic between a member of sales and printers on the network, but we don't have a policy in place. We want sales to be able to use the printers, but we want to limit potential exploitations of those printers. We can deploy a more granular policy that limits traffic to only the protocols required to use the printer. You can apply this method throughout the network between any sets of users and devices and applications using our powerful policy language. I want to quickly demonstrate our identity-based policies being enforced on our Elisity secured network. We have our user Olivia Douglas, who's an administrator in Active Directory. Her policy as an admin grants her full access to most of the network. So from Olivia's machine, we're going to SSH onto the Raspberry Pi to show our ability to limit traffic between unmanaged devices. Now let's run a ping to the printer on the network from this Raspberry Pi. You can see that this flow is allowed, and we can see that reflected in the policy from media servers to printers in Cloud Control Center. Let's change this policy to block all traffic. So we'll simply switch from all traffic allow to all traffic deny, and after we deploy here, within a matter of seconds, traffic is blocked to the printer. We were able to implement this policy without needing the IP address or the MAC address, only each device's identity as a printer and as a media server. Every device that comes online is identified in this way and is immediately applied to the correct policy group. We do the same with users and applications. We're really just skimming the surface of what this platform is capable of. So thanks for taking a few minutes to learn about what Elisity has to offer. If you'd like to learn more or see a full demo, you can check out our website at elisity.com.